Hello friends, in today's video we are going to see more related topics to lambda expressions and exceptions. A lambda expression can throw an exception. Okay, so if there is a erroneous condition, it can be thrown by lambda expression. However, if it is throws a checked exception, then that exception must be compatible with the exception listed in the throws clause of the abstract method in the functional interface. Okay. So whichever in the exception, if it is throwing, that exception must be compatible with the throws clause of the abstract method in the functional interface. That is the only one method declared in the functional interface which has no body, no definition. It should have the throws clause. For example, integer add throws illegal argument exception. Okay, so it must be the case in the functional interface definition. Here is an example that illustrates this fact. It computes the average of array of double values. Okay. If a zero length array is passed, it shows the custom exception empty array exception. Okay, that is the exception to this exception throwing case. The array length should be more than 1. If it is zero length, it will throw empty array exception whether or not it has declared the exception. This exception is listed in the throws clause of function declared inside the double numeric array function functional interface. Okay, empty array exception is a custom exception thrown by double function double n. Here we will be passing an empty array so that it will throw empty array exception. Class empty array exception extends exception. Okay, and it will show array is empty. Now in the main function, it throws the empty array exception double values 1.0, 2.0, 3.0, 4.0. Okay, double numeric array function average n. Okay, so here we are passing the n, double sum is equal to 0. If n dot length is equal to 0, throw new empty array exception. Okay, and if that is not empty, then it will be like this: I is equal to 0, I less than n dot length, I plus plus, sum plus is equal to n of I. Okay, return sum divided by n dot length. So what it has to compute? It has to compute the average, right? Okay, so double numeric array function average is equal to sum is equal to 0, and if n is not equal to 0, then sum will be added. All the numbers provided in the array will be added and it will be divided by n dot length. Okay, the average is average dot function of value. So here what we are passing, what is average over here? This is the reference variable of double numeric array function functional interface. Okay, double numeric array function, this is the functional interface name, right? And then average is the name of that reference variable. Here we are passing n. Okay, and here we are passing the values. Okay, so where we have declared the values 1.0, 2.0, 3.0, 4.0 as a array, right? Next, the average, this will create the average of 1.0, 2.0, 3.0, 4.0. That is the first case. This will not throw any exception. And next statement is the average is average dot function new double of length 0. So of which number it will calculate the average? It will not calculate. Okay. So in this case, it will throw the empty array exception. The first call to average dot function returns the value 2.5. The second causes the zero length array causes an empty array exception to be thrown. Okay. So the inclusion of throws clauses function is compulsory, not necessary. It will be compulsory most of the time. The program will not compile because the lambda exception will not be compatible with the function. Okay. So here it should throw the empty array exception, and here in the lambda expression definition, here in the opening and closing bracket, it will be able to throw new empty array exception. If this is not throwing anything, then this will not be throwing anything. Okay, this will not be able to throw any exception. Okay, this example will tell you another important point regarding lambda expression. The parameter specified by function in the functional interface double numeric function is an array. Okay, what is having? It is having an array, double array n. Okay, and when it will be zero length array, it will throw an exception. Okay, the parameter to the lambda expression is simply n rather than n array. The type of lambda expression will be inferred from the target context. Okay, so here we are only passing the name, that is the copy variable name n. We are not passing it as n and opening and closing square bracket to tell that it is an array. We just have to pass the n, and the target type will be target type of lambda expression will be inferred from the target context in which we are executing the lambda expression. Here the target context is double array, so it will be casted to double array. This will be converted to double array. Okay, so whenever we are passing the value array, we should be passing only double array. Otherwise, it will not run. It is not necessary or legal to specify it as n array. It would be legal to explicitly declare it as double n, but doing so gains nothing in this case. Okay, we can declare it as double n like we have seen in the previous example. We can pass the parameter type over there, but here it will not give anything extra in this case. So simply you will just pass the n. Okay, it will be as simple as that. And how you will understand that which is the type? It will be inferred from the target context. Lambda expression and variable capture. Variables defined by enclosing scope of a lambda expression are accessible within the lambda expression only. Likewise, the scope and lifetime of the variable we have seen while introducing the Java. Same way here also, variables defined in the scope of the lambda expression are accessible within the lambda expression itself. A lambda expression can use an instance or static variable defined by its enclosing class. Okay, a lambda expression also has access to this, both explicitly and implicitly, which refers to the invoking instance of the lambda expression's enclosing class. Okay, variables defined by enclosing scope. Lambda expression can use an instance or static variable defined by its enclosing class. So in whichever instance, whichever object or static member declared by its enclosing class can be directly used by lambda expression. A lambda expression also has access to this keyword, which refers to the invoking instance of the lambda expression enclosing class. Okay. Thus, the lambda expression can obtain or set a value of instance or static variable and call a method defined by its enclosing class. Okay. A lambda expression can give you obtain or set the value of an instance or static variable and call a method defined by its enclosing class. Okay. So get value can be done as well as set the value of an variable can be also done. Okay. And can call a method defined by its enclosing class. When a lambda expression uses a local variable from its enclosing scope, a special situation is created that is referred to as variable capture. Okay. So whenever a lambda expression uses a local variable from its enclosing scope, local created variable, that situation is called as variable capture. A lambda expression may only use the local variables that are effectively final. Okay. Lambda expression may only use the local variables that are effectively final. So those should be a final keyword variables, right? Those will be final variables. An effectively final variable is one whose value does not change after it is first assigned. Okay. So those will be final variable. There is no need to explicitly declare such variable as final, although doing so would not be an error. But the effect of it should be final. That variable should not be changed. Variable value should not be changed. This parameter of an enclosing scope is automatically effectively final, and lambda expression do not have a this of their own. Okay. This parameter of the enclosing scope, that is opening and closing curly braces, it is a final. Okay. Enclosing scopes, this keyword parameter is automatically final, effectively final, and lambda expression do not have a this of their own. Okay. Local variable of the enclosing scope cannot be modified by the lambda expression once declared because they are effectively final. Doing so will remove its effectively final status, thus rendering it illegal for the capture. Okay. So what we have understood in this case, local variable situation. Okay. Local variable means whenever lambda expression uses a local variable created inside the scope of the lambda expression, that is opening and closing. First of all, they are called as capture, variable capture. Second, they are final, effectively final variable. No need to declare them as final, but their output should be the final. Likewise, this value should not be changed. Okay. And no need to write them as final. This parameter is already automatically effectively final, but lambda expression do not have this of their own. Okay. And the last point, the local variable of the enclosing scope should not be modified by the lambda expression because those are effectively final. And if you will change the effectively final variable, it will not be useful for your local variable capture. Okay. So that you should not change the value. The following program, in this following program, we will see the difference between effectively final and mutable local variables. Okay. An example of capturing a local variable from the enclosing scope. Interface my function, integer function, integer n. Okay. So interface is declared integer function, integer n. This is the declaration. Example of capturing a local variable from the enclosing scope. This is the interface, which is the functional interface because it is having only one method. First criteria. Second criteria is it is having no method body. Next, class variable capture, public static void main, a local variable that can be captured, integer number is equal to 87. Okay. This is the local variable. Okay. Integer number is equal to 10. My function, my lambda. Okay. This is the function interface name. This is the reference variable name. Passing parameter as n. Okay. Integer n is passing, so it will be inferred as an integer. This does not modify number. Okay. Integer b, that is value number plus n. Okay. So number is a local variable and n is a it is 10 and n is a value whichever we will be passing when we will execute the lambda expression. The following is illegal because it attempts to modify the value of number plus plus because it is a effectively final variable, local variable from the enclosing scope. Okay. Next, and return B. So you should not modify this because it is a effectively final. It is not declared final, but it is inside the enclosing scope. So it will be declared as effectively final. Next, the following is illegal because it attempts to modify the value of num. Okay. So we are also doing it here. Number is equal to 9. It will be modified because it would remove the effectively final status from the number. Number is effectively final and can therefore use inside my lambda. Okay. So local variables used inside the enclosing scope will be the variable capture. And if you want to capture that particular local variable inside the enclosing scope, what do you mean by enclosing scope? This lambda, okay, this lambda definition where it is enclosed in this public static void variable, and any variable that is declared with a value that will be effectively final, and if that lambda where it has declared in this enclosing scope opening curly brace of public static void main and closing curly brace of public static void main. Inside we have declared this my lambda, right? So its enclosing scope will be public static void main. Okay, first thing. And second thing, which variable is declared like it has assigned value? Because whenever we are creating a final variable, we are assigning the value to it right there. Okay, whenever we are creating, at that moment only we are giving the value to that particular variable. So here we are giving value to number, right? So this is the effectively final variable. And if this lambda needs to use this local variable number, which is effectively final, what is the rule for that? It should not modify it. It can directly use this like number plus n, but it cannot use it like this number plus plus. It cannot modify this variable. Okay, so this is the motto of this particular program. If number were to be modified either inside the lambda or outside of it, number would lose its effectively final status. This is the main thing we have to understand from this program. This would cause an error and the program would not compile. It is important to emphasize that a lambda expression can use and modify an instance variable from its invoking class. Okay, lambda expression can use and modify instance variable from its invoking class. Okay, invoking class means who is invoking that particular lambda. It just can't be the local variable of its enclosing scope unless that variable is effectively final. If it is effectively final, then only it cannot modify it. Okay, but still it can use and modify. If it is not final variable, it is just declared. Then it can assign a new value to it. It can increment it. It can decrement it. It can add some values, some points to it. It can divide, it can module, it can do anything on that variable if it is not effectively final, if the value is not assigned at the time of declaration. And plus lambda expression can use and modify instance variable from its invoking class. Okay. Next, method references. There is an important feature related to lambda expression called the method reference. A method reference provides a way to refer to a method without executing it. Okay, so we will refer to a method, but we will not execute that particular method. How it is possible? When we are referring the particular method, we are indirectly call it. So how it is possible? We will see that. It relates to a lambda expressions because it too requires a target type context that consists of a compatible functional interface. Okay. So here also this method will be referred because it should be first of all it requires target type context so that the primitive type will be inferred according to that target type, and also that consists of compatible functional interface. Okay. When evaluated, a method reference also creates an instance of the functional interface. Okay. When we will evaluate the method, method reference also creates an instance or reference variable of the functional interface. Okay. So method reference will create a reference variable of the functional interface. There are different types of method references. We will begin with the method references to static methods. Okay. First is method references to static methods. To create a static method reference, class name, scope resolution operator, method name. Okay. Notice that the class name is separated by the method name by a double colon, and the double colon is separated added by Java 8 expressly for this purpose. The method reference can be used anywhere in which it is compatible with its target type. Okay, so its target type should be able to be inferred. Okay, so in that case, anywhere it can be used. Now, following program demonstrates a static method reference, a functional interface for string operation, interface string function, one method string function, string n as a parameter. And now this defines a static method called string reverse. Okay, static string, string reverse, string string. This is the static method. So this can be called without using the object of myString OPS. We can directly call it. Okay, string result integer I. Okay, so what we are doing here, we are reversing the string or characters inside that and returning the result. This method has a functional interface as at the type of the first parameter. Okay, functional interface as the type of its first parameter, and thus it can be passed any instance of that interface, including a method reference. So here we can also pass the method reference. And how to pass the method reference? Like this: class name, scope resolution, method name. What is the class name over here? My string OPS. And what is the method name? String reverse. So how you will pass it? My string OPS double colon string reverse. And what it will be evaluating to? Reverse string. And what will be the input string? This will be the input string. Okay. So how you will call this? Return SF. What is SF? We will see now. What is SF? This is the string function SF. This is the functional interface reference variable name SF, whatever we are passing while calling this method string operator. Okay, SF dot function S. So S is the input string. Okay, this is static, so it can be called without object. Here also out string. Out string is equal to string OP. Okay, static string string OP. Okay, and in this we are passing it as my string OPS, class name, scope resolution, function name string reverse, and this is the input string. What is input string? Lambdas add power to Java, and our output string will be reversed characters in that. Okay. Next, original string and output string is displayed over here. Lambdas add power to Java and reverse string is displayed over here. Okay. Now we will see the in detail. Out string is equal to string OP. Why without object? Because this is the static method. This is the this is what our method reference to static method. Okay, and this is the input string. Okay, reference to a static method string reverse declared inside my string OPS class is passed as the first argument, and that will be evaluating to reference variable name of the functional interface. Okay, this works because string reverse is compatible with string function functional interface. Okay, so it is also having one parameter which is string and returning string. Okay, the expression my string OPS double colon string reverse evaluates to a reference to an object in which string reverse provides the implementation of the function in the string function. Okay, string function is a functional interface name. Next, method references to instance method. To pass a reference to an instance method on a specific object that is not static. Okay, so like object name dot method name. Use this syntax: object reference name double colon method name. The syntax is similar to the static method, but here we are using the object reference instead of class name. Okay, so here we will be passing the object reference double colon method name. Here is the previous program rewritten to an instance method reference. Okay, this is the functional interface same as previous. This is the this class defines instance method called string reverse. Okay, this is not a static method. So how you will operate on it? My string OPS object name obj dot string reverse. We have to create the object of this class and then we will call this because this method is not static. Okay. Then this will be reversing the result. Then this method has a functional interface as the type of its first parameter. Thus, it can be passed any instance of that interface, including method references. Here, this method is still it is static. Static string op function sf string s, and this will be here we will be passing object reference double colon method name, right? And it will be returning the reverse string. Input string will be passed over here. Okay. Lambda's add power to Java. This is the out string. And my string OPS, this is the object name we have created. And object name double colon method name we are passing to string OP. String OP is still static. So here we cannot, we should not create the object of that. Okay. So string OP in bracket, string OPS, string reverse, input string, original string and output string will be displayed. And this will be producing same output as the previous version. Notice that string reverse is now an instance method of the myString OPS. Inside main, an instance of a myString OPS called string OPS is created. Okay. Inside main functions, for instance of the myString OPS class is created, object is created, and using that object string OPS double colon string reverse input string. Okay, and this will create the reversed output. String reverse is called on the string OPS object, not the class name. It is also possible to handle a situation in which you want to specify instance method that can be used with any object of a given class, not just a specified object. Okay, you will create a method reference like this: class name colon instance method name. So if you want to call that particular method with any object of the given class, not just a specified object. So instead of the object name reference, you can directly give the class name over here. Here the name of class is used instead of the specific object, even though instance method is specified, and this is allowed in this case. The first parameter of the functional interface matches the invoking object, and the second parameter specified by the method. Okay. With this form, the first parameter of the functional interface matches the invoking object. Okay, and the second parameter matches the parameter specified by the method. So now we will see the example. This defines the method called counter that counts the number of objects in an array that satisfy the condition defined by the function method of the my function functional interface. Okay. Now we will create the method called counter that counts the number of objects in an array. how many objects are there. That says that satisfy the condition defined by function method of the interface. It counts the instances of the high temperature class. Okay. So this is the generic interface, generic functional interface. Interface my function t, boolean function t value 1, t value 2, returning boolean true or false. The class that stored temperature high for the day, high temperature, private integer high temperature. This is the parameterized constructor initialized with the high temperature. The return true is the invoking high temperature object has the same temperature as the ht2. Okay. If this high temperature initialized while creating the object of the high temperature class, this high temperature is equal to the past temperature, then it will return the true as a result. Return true if the invoking object as a temperature has a temperature that is less than ht2, boolean less than temperature, high temperature ht2, return h temperature less than ht2 dot h temperature. Okay. The next method with the object reference demo, a method that returns the number of occurrences of an object for which the same criteria specified by the my function parameter is true. Okay. Static t integer counter, t value my function t, f and t value. Okay. So this is the counter function. Here it is having the array of particular type t that will be same as static t, returning t, my function interface, that type should be same. This is the reference variable of the functional interface, and value is t p. Okay. For all values dot length, what we are doing, f dot function values of I comma v, we are counting the high temperatures and return the count. Okay. New high temperature 89, new high temperature 82, 90, 89, 89, 91, 82 and 83. Okay. Use counter with arrays of the class high temperature. Notice that a reference to the instance method same temperature is passed at the second argument. Weekday high temperature, double colon, same temperature, new high temperature 89. Okay. So count days had a high of 89. Okay. How many days was having this high temperature? Okay. That will be counted in the count variable. Now create and use another array of high temperature objects. High temperature weekday highs to 32, 12, 24, 19, 18, 12, minus 1, 30. Okay. Then again counter weekday highs to high temperature double colon same temperature, new high temperature 12, count days high of 12. Okay. Now less than temperature, to find days when temperature was less than a specified value. Okay. So here we are passing the less than temperature, new high temperature 89, less than the 89. Count days had high less than 89, and again count days had high less than 90. 3 days has 89, 12, 89 and 90. Okay. So this way we have understood different topics related to lambda expressions. Okay. Still some theory is remaining over there. So in the next chapter, in the next session, we will try to cover this chapter, complete the theory part, and then we will move forward for the practical part. Okay. So meet you in the next session with the more interesting theory topics. Till then, you can enjoy the session. If you are not understanding anything, you can go back and join again, and again revise the things, memorize the things, capture the screenshot, and or you can note down your notes so that in later on you can understand the same lambda expression twice. Okay. So meet you in the next session. Thank you so much.